the spikes, the green spikes. On
Yes, 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 I see.
And that's the individual beam position monitors all around the LHC.
Yeah.
4 times. Okay, I'll give Diogo a call. All right.
Ah.
Let's see if he can help me.
He doesn't trust it?
Yeah.
No, he cannot go. He cannot continue like this.
Ah. So the second stage has started. We are well advanced with the process of getting to the stable beams status. So where are we now?
So presently we're ramping. I just look at the display. So we're at 4 TeV. We have to go
Per
to
beam.
6. Yeah, per beam. So we have to go to 6.5 TeV per beam, which gives the 13
Yes.
TeV center of mass, and still ramping. So for the moment things go well.
So far, so good.
So far so good. And we hope that the 3 bunches will make it to the top energy, and then we will do the squeeze and put the beams in collision.
Okay, so we are patiently waiting for these next stages to happen
Yes.
until stable beams.
Indeed. Yes, CMS.
And we are one step closer to stable beams because we reached the nominal energy of the LHC in its present configuration.
Yes,
that is the
indeed.
flat top, so-called.
Yes, so we're presently on the flat top, and just now the mode has changed from flat top to squeeze.
And that's
So
great. So
this is-
an
this
extra
is-
step right
Exactly.
now.
This is the very next moment. So this is when we start reducing the size of the beams in the experiments
Yes.
before going into collisions.
The
so
thinner
that
the better, right?
Yes. So the more dense you have the beam, the more collisions you will have. And this is the
Okay.
idea of the squeeze. So you change the quadrupole magnets around the experiments in order to make the beam size as small as possible, and therefore we'll have more collisions.
And what's next?
So the next step will be to finish this squeeze. This will take about 10 minutes
Okay.
for all the power converters and the magnetic fields to reach the correct values. And then the next step will be to put the beams in collisions and then do the adjust. And this means that we will adjust the beams in order to maximize the number of collisions. So we steer the beams really head on so that the number of collisions will be maximum
Yes.
for
So
the
you
experiments.
adjust means they're still kept in parallel,
Yeah.
running parallel inside
well, not
the
in that
LHC.
moment, but
And then you
collapse, and then we
collapse.
adjust. Yes,
which means they will be colliding
exactly.
in the center of the 4 detectors around the 27-kilometer ring of the
Exactly.
machine. Okay, so that's happening very soon. I've seen another change
yeah,
of color in the.
Yes,
what's
but
happening?
this is the display of all the power converters, and
Yes.
and every time these power converters will change the current, we see the color changes on the display, and we see if all these power converters follow
I've
or
seen
not.
them going from green to violet. It's now yellow.
Yellow, yeah. So these are the different states, and the idea is that once we reach a stable state of the power converters, they become green again
Okay, so
And,
that's the sign for us to.
to end the squeeze.
Another step made towards stable beams. We are in adjust mode, right, Rende?
Yes. Right now we are in adjust mode, and this will take a bit of time, and then the beams will collide. So it's a matter of waiting. As you perhaps can see already, some
Everybody's
people,
waiting.
Additional people are gathering here in the control room.
And I'm sure in the
To-
4 experiments control room, they're all waiting
I think
for
so.
this
They're very
moment.
excited as well to see the first collisions in stable beams again.
So adjusting, let's explain again, what does it mean exactly, adjusting the beam before collisions?
So what we need after having done the squeeze, we need to put the beams head on. So we have to get the beams colliding, and then here the operations team, they will also optimize these collisions. So this means that
Perfect.
they steer the beam in such a way that you get the most collisions out of this beam.
So they get the best possible beam for the 4 experiments.
The highest number of collisions, yes.
Okay,
So there, I think
we are moments.
we're going
waiting for this
to
moment.
collapse the beam.
Which is the screens you're
Yes.
looking at most?
Presently I looked at the power converter display because this announces the change of the power converters, and then we will look on the display. You see the display with the 3+3 over there,
Yes.
and then next to it is the display where we see the luminosity monitors of the experiments.
Okay.
So.
Okay. It's just
So
a matter of waiting right now.
It's now a
It
matter
could be
of
any
waiting,
time.
Yes. So if you look on the display now, you see that the collisions are there in CMS.
Yes, but the
And
experiments
also-
are not on again.
No. This is not yet the collisions for the
So
stable beams.
this is collisions mode of the machine.
This is
right?
in adjust. Now we have collisions in adjust mode. So now the
Voilà.
people are adjusting these collisions, and then afterwards we're going to declare stable beam.
And then the experiments will switch on.
And then, only then, the experiments will start taking the data.
Okay.
They are switched on, but they're in
Not
standby.
completely. They're in
Exactly.
standby.
Yeah.
Exactly. Okay.
Exactly.
So it's a matter of seconds, minutes.
Well, this
Moments.
depends on the adjust time we need. So this is the operator that will declare it afterwards.
Okay.
So,
The
right.
sequence is launched.
The sequence is launched, so now they're going to push the button. Marcus?
Marcus,
go ahead.
is real a button? Is
Yeah,
it really?
he is well. It's on the screen, but he pushes
It's
the
a button on the screen
and
to
then
make
he-
the beam collapse.
Well, the beams are already colliding,
Okay.
but now they adjusted it, and now they will tell
Give the
tell the experiments that they can start data taking.
Okay.
And now, stable beams.
Stable beams exactly at 4:31 p.m.
Yes.
on the 23rd of May 2017. The physics season has started at the LHC for 2017.
Very good.
Thank you.
Nice.
Hey guys.
Hey. Bravo.
And welcome back to the CERN Control Center. You've just seen the major milestone just accomplished yesterday, 24 hours ago, here from this room. First beams for physics started yesterday, the 2017 physics season, 2017. So we are here around this table with experts, physicists from the 4 experiment and from the LHC machine, to whom you can ask your question. Post your questions in the space right below this video box, and we will answer very soon. But first, let me introduce the guests around this table, starting with the LHC machine, Jamie Boyd. Jamie, hi. He is the LHC coordinator. Your role is sort of an ambassador between the LHC collider and the experiments. Tell us
Yeah,
why.
exactly.
Why do we need that? Why do we need you?
So my main role is basically to take requests from the different experiments and then try to come up with the configuration of the machine, running scenarios for the machine for the year that will satisfy what the experiments want, which sort of starts off before the run and is relatively, we come up with a plan, but then of course as the run progresses, what often happens is, we have issues which we have to change the plan at the last minute, and this requires sort of following very closely how the accelerator is working and also how the different experiments are working.
And you have to be very diplomatic, I guess, because there are 4 experiments, each with their requirements.
Exactly, we have to try and come up with the best solution to come up with the best physics to get out of the LHC, basically. So try and take into account the requests from all of the different experiments.
And talking about best physics, yesterday, of course, you were here, you were going through these fantastic milestones, you achieved first stable beams of the season.
Yeah.
Tell us, what's the difference between yesterday and the other seasons that we started in the previous years? What changes this year?
Yeah, this is a good question. So in order to try and get more data to the experiments, which is really the main goal of the LHC, we've tried to optimize the configuration of the machine. We try and squeeze the beams in a slightly different way than was done last year, which can give us more data. And we've also tried to remove some of the limitations that were in the machine last year that occurred during the year in the accelerator to try and be able to give more data to the experiments. This is really the name of the game from the accelerator side.
And we are constantly optimizing this fantastic machine.
Exactly.
Thank you for now. Stay here because I'm sure there will be questions coming from our live audience. We now go through all the experiments, starting from Atlas. Atlas is the largest of the LHC detectors. It's based in point 1. You can see on the map here. It's the experiment, the only one on Swiss territory, 100 meters below ground, Switzerland. So Alexander Ho is our Atlas physicist today. Yesterday, of course, you must have been in the control room as well, and it must have been, once again, an emotion to go through this first collisions day.
Yeah, certainly it was a great event to see stable beam collisions again in 2017. And we had lots of work was going into the detector because we had to prepare for new conditions. LHC did a great job of providing more collisions, as Jamie was saying. And this requires us, of course, to adapt our experiment so it can handle these more collisions. So there was quite a lot of work, new pieces of equipment were installed, a lot of things had to be followed up with these stable beams. So we had 5 different things going on at the same time, commissioning new pieces of equipment. And I must say it was really very, very exciting to see the first event on the display.
And we just seen them. I hope
Yeah.
we can see them again. The first events, they were recorded exactly yesterday.
Exactly,
Here they
there
are.
you see it so beautifully. You can see all detector components give you a signal in the spectacular event. You see a little muon there escaping to the upper left on the lower left screen there. So all the components worked beautifully together, and we could reconstruct this event, so it was really very, very exciting. And then, of course, after the first event, it subdued a little bit, so we were collecting more and more data, did all our tests, went through our program, which we planned ahead of what we would do with this first fill. And, yeah.
That's great. So now you have a better machine, you have more data. What's the plan for 2017 for Atlas?
So for Atlas, of course, the aim is to collect as efficiently as possible the collisions delivered by the LHC. So last year we had something in the high 90s, and of course we want to keep that performance, even though we will have more collisions this year. So we want to keep it on that level. And then with this data set, of course, we will roughly double what we had before at 13 TeV. So apparently we look for new signals in physics, new features, which is not described by the standard model. This is one program, a large chunk of the program of Atlas. And then, of course, on the other end, you have also precision measurements of known processes. And then you look for tiny deviations of what the theory really tells you it should happen. And then this could also be a sign of new physics. So this is the other branch of Atlas. And there's also many more physics channels to be looked at.
So you're very busy. You will be very busy. And I'm sure there will be a lot of questions coming up for you. Let's now cross the LHC ring from point 1. No, they have a microphone here. From point 1 to point 5, interaction point 5, right above the circle up there, under French territory, sits another big detector, CMS. And we have here for CMS, Anne Dabrowski. Welcome, Anne. So tell us, how was the start of physics at CMS yesterday?
Incredibly exciting. During the year-end technical stop, so over Christmas and January and February, we installed our new inner tracker detector.
We did a Facebook Live of that as well. You can view it again. It was a fantastic operation, a heart transplant. It was dubbed by journalists.
Exactly.
Yes, it was a major operation.
Exactly, yeah. This was the culmination of 5 years of detector construction work. And so our first stable beams yesterday gave us an opportunity to switch on this detector and see its first signatures with collisions.
So the heart is beating again
the
in
heart
CMS.
Is beating. Yeah.
Fabulous.
So the program was dedicated to timing in the detector, all the different layers. We have 120 million pixels.
And you recorded first events already.
Absolutely.
You brought events. There they are. Look at that.
There you can see